The video you are about to see explains the goings-on inside of this brand new invention, the Gogins Transmission, and it'll go through the details of its operation and the principles of its operation for you to see. You'll see that it shifts all the way down to 0, and it'll shift all the way up to any design top speed. And the machine you're looking at is run by a flea power motor. It's a 1/100th horsepower clock motor right here, and it has an input shaft right here. Maybe you can see it better if I use this pointer. And it's got an output shaft right over here. And you can see the rotation of the shaft by the movement of the keyway around. The motor turns at 30 RPM. So we have a big reduction, but we can shift all the way down to 0 and up as far as we want to go with this device. And while it's called the Gogins Transmission, I'm called Laird Goggins, and I'm the inventor of this transmission and the owner of Gogins Transmission Group. Let me tell you more about it. It's an infinitely variable transmission. That means that the speed, as mentioned, goes all the way from 0 all the way up. And we do that by moving this little control screw right here. And you'll see that as I move it in this direction, this is going increasingly slow. Now, it's a totally ripple-free, very smooth output at all speeds and during the interchanges between all speeds. And I get the top speed by moving this control this way. And I won't go all the way up to the top, but I'll go up far enough so that you can easily see the difference in the outputs and the speed of the output shaft relative to the input shaft. So we go up this here, and now you'll see that this shaft here is moving. This is the output shaft, so that its keyway is coming up and going a whole lot faster than 0, but not very fast indeed. You can see it go, and this is a desktop prototype. And that desktop prototype is mounted so that we can show it to you right on your own desk in your own business, and you can have your cohorts there to look and question at any time. Let me go from the beginning. This is a 2.5 horsepower device if it were running on its own and at 1750 RPM, with the output shaft going at 1,000 pound-inches of torque easily. The output shaft right here will develop 1,000 pound-inches of torque on this very model at this size, and you can see that's not a very big device. One of the features of the Gogins transmission is its compactness and its lightness of weight. It's very light, and so in an automobile where you have cramped quarters, it'll go in very nicely. If you've got it on an irrigator that's moving across the soil, it'll carry very nicely, and it's all waterproof from beginning to end, from input to output, and is lubricated by a mist lubrication inside the housing. Let me show you the input side, which is right here. The input side.
Okay, start that one sentence again. Let me show you the input side.
Let me show you the input side. I'm going to get up from my chair and walk around to make it easier to explain. The input side is comprised of this input shaft, and there's a cam, one right here, and there's another one right here, 180 degrees out of phase, one with the other. And those cams drive cam followers up and down, and they run as they're going up at a constant speed. And this one is going at a constant speed, and we show that we're holding those in contact, those members, the cam follower and the cam, with springs. However, in production, they're just held together by hard springs, which means we have one more cam right out here that keeps the follower in contact with the driving cam at all times without having to have any sort of spring assistance whatsoever. Let me push on that description, you'll note that those cams and cam followers have line contact. And at line contact, they handle either easily 100 times as much power as they would handle on point contact as you have in, say, the Van Mooden push chain sort of arrangement, the CVTs. And so this will put out lots more power than the push chain devices could dream about putting out. And of course, it's got an enormously wide ratio range, and it can be shifted with a finger-like touch. Now those cams are slidable on this input shaft. Here's the input shaft, right here. And if I move this, you'll see that the cams and the mechanism associated with the cams is moving right along, but the input shaft isn't moving. And that's because the camshaft that carries all the other parts is going to be, and is indeed in this model, ball splined to the input shaft. So we can move it very easily from one end to the other. And when we move it to the one direction, we get zero output. When the up and down cam motion is in line with the power takeoff. And I will turn it around and show you the power takeoff side in just a minute. So the oscillating motion that you see there is, and I'm going to turn this around, converted to rotary motion over here. I'll come around once again. And the rotary motion is carried through a lever. See the levers right here and right here? And those levers are pinned to the cam follower that goes up and down. And as it's going up, it's going at a constant speed. As this one's going up, it's going at a constant speed. Turns. Want to stop?
Yeah. We'll have to go back to that one.
Okay. And check with your mic.
Okay, can you hear me now?
Yeah.
Okay. So, shall I just start?
Yeah, let's just do that one.
So the cam on the other side is pushing the cam follower up and down at this speed, and here's a lever being driven by one of the cam followers, and here's the lever being driven by the other cam follower. You see it in there? And so if I move this device one way or the other, this power takeoff will go to where the zero cam lever motion is right here, and all the way up to the top speed over there. And in this model, there's a rack gear right in this device right here, and that rack gear meshes with the spur gear teeth outside of these one-way clutches, and those one-way clutches take turns driving the output. First this one drives it, then this one drives it, and this one drives it, and that one drives it, and this one drives it, and that one drives it, so that we end up with a constant speed right over here. Now the interim place between in the operation is demonstrated by tipping this on its face, and you'll see that lever being guided on a semi-cylindrical gear bearing that's on the lever. So as the lever twists back and forth, the takeoff from it will go straight up and down on these guideposts to produce the ripple-free motion for the one-way clutches. So we have the two cams on this side, we've got the two levers in the middle, and we've got the two outputs over here. And there's nothing but line contact, or better yet, a big broad sliding gear type contact in the power path from the front end to the back end. First, all of the energy is going through this half of the transmission, then all of the energy is going through this half of the transmission, just like all of the energy comes from this piston in a two-cylinder engine, and from this piston in the two-cylinder engine. They take turns driving whatever they're driving.
Ready again.
Okay. So you'll see that the cams driven by the input shaft over here move the cam followers up and down. The cam followers are right here. And so as they go up and down, they move this lever. And the lever, other end of the lever is pivoted right around this point here. That's the fulcrum of that lever. And the face of that lever is a rack gear. And that rack gear engages spur gear teeth cut on the outside of these one-way clutches, which drive the output shaft. It's line-to-line contact at the cam and cam follower. It's line-to-line or broad surface contact on the bearings in the takeoff and to the lever, and it's a line-to-line contact between the rack gear and the gear on the output clutches. That's why we can handle so much more torque with the Gogins transmission than you can get with, say, the push chain devices, which depend upon point contact from the little axles for the links that make the chain up along the way. And there's only so many pounds of force, and it takes an enormous force to shift those devices, because you've got to handle a shifting of heavily loaded devices that are grooving in, are trying to seat themselves into the cone-shaped pulleys that they're riding on. We don't have those sort of things. As a matter of fact, as you notice when we shift this, this is called the shift block, and it'll travel back and forth. And although it's not shown here, we have a little groove cut in the production models with two rollers separated by a little compression spring, so that if nobody's moving the retainer that holds those levers, it'll be locked. There'll be one rod against one inclined plane and another rod or roller against the other inclined plane, and you can't move it. But because underneath that device you have levers going up and down, the forces generated are going to be first to the left and then to the right from reaction forces on those levers. So if I were to pull this little carrier one way, then that roller would be pulled away from that particular wedge in the steering column here. And as it does that, that means it could coast in that direction, driven by the levers underneath. So our shifting power it's a self-powered device. You don't have to provide any power from any place else. It's a self-powered device, and it'll self-lock as you come through. And there's one other aside I should make here too, and I'll probably make again, and that is that instead of having the teeth on the rack and the teeth on the clutch, we can have just no teeth on the rack, just like it's a plane going up and down, and no teeth on the output of the clutch, which is just now a wheel, and we press that wheel hard against the no teeth type rack, the rack gear with no teeth, and it can roll on it, and it'll roll in one direction to push it up and roll in the other direction to push it down, and it's run by a cam that switches it, and the cam is going at the same speed as the input shaft. So we have a clutchless device that can be not only driven from the motor or the input side, but it can be driven by the load side as well. So we could have compression braking if it was in an automobile. And it's not going to run away down the hill if you're doing a irrigator and using it on a hill slope on the farmland itself. So it's a neat sort of development along the way. The outputs from the car transmission, we've just done that theoretically and mathematically, range from 0 up to 2.5 times the input speed. And because of that extraordinarily wide range, which is really an infinite range, substantially larger than about a 6-to-1 maximum range that you can get out of the push chain devices used in cars, CVTs, or the toroidal combinations of rollers that you could try putting in automobile application. So the range is, so because of that were in a car, it would give you 1 times as many miles per gallon. Or putting it in another way, the device will provide in the automotive application easily more than 400 foot-pounds of torque in a compact device, and it will indeed run at a 8-speed to a 12-speed engine on the bigger vehicles, as well as the small vehicles, which will be very small. So with that in mind, with 1.5 times as many miles per gallon, if we could suddenly put this transmission in all of the automobiles on the road today, we would be saving 92 million gallons of gasoline a day. 92 million gallons of gasoline a day that we don't need to be buying, that we don't need to be importing, that we don't need to use in our automobiles, and it will save 500 pounds of emissions each day. Each day, 500 tons, rather, of emissions that will help keep our air clean, and a bigger contribution to that I do not know of. It's a wonderful little transmission, and it makes the machines that it's put into new and wonderful in and of and by themselves because of the inclusion of the transmission. Comment on that, we could have the device easily put into a snowmobile, and when you had it into a snowmobile, which has a belt drive, and when your belt drive grabs, if you're in light powdery snow, it grabs with a jerk, and it sinks this snowmobile into the snow instead of moving it forward through the snow. But with our device, you could feather start it and inch along until you get going through the snow without any of those problems whatsoever. It could go in a washing machine. It could go in a bicycle. And as a matter of fact, we've just finished the building of the parts for a bicycle transmission, which kind of looks like a 21-speed transmission of the derailleur type, except we never have to move the chains from one sprocket to another. We just keep them on the same sprockets at all times. And while it looks the same, it's only got about less than half as many sprockets. And furthermore, it has a little cam that you can see hooked right to the pedal, just like this has its cam. And the pedal is the input of the bike, and the motor shaft is the input to this transmission. By the way, the saving on the I look at my note here, and the saving on the pollution is 5.4 thousand tons per day. Not 500, but 5.4 tons of power of emissions per day. So there you have it. Let me just summarize it. We have a marvelous new transmission, I say, and I think you will agree. It's very simple. It's got 5 parts. Any time. Part 1 is the cam. Part 2 is the cam follower. Part 3 is the rack gear that's driven up and down by the lever. And part 4 is that lever. And part 5 is the output shaft. And of course, you don't have to have a one-way clutch on an automotive device because we want to have engine drive and engine being driven by. So the engine drive moves the car along, and the engine is being driven downhill by the rotation of the output wheels. And what's nice about it, instead of just being at a given ratio, it's at an infinite variety of ratios that you're getting at braking power. Vastly more efficient. So if you have any questions, or if you have additional information that you want, please feel very free to contact me. And thank you, Mark.
All right, thanks, Larry.
And thank you. interest and for looking, and I'll look forward to hearing from you in the very near future. By the way, other applications, as you'll see by the pictures of the automobiles and helicopters and bicycles, we talked about those. If you were to put this device into a helicopter, that helicopter would go 30% faster than it will go now, because now, in order to slow the rotors down, which you must do when you're going faster in a helicopter, otherwise the tip speed on those rotors will exceed the speed of sound. So with that, in our device, we can slow the rotor down with the Gogins transmission while having full power driving the rotors instead of partial power driving the motors as the rotors go slower. I don't care what you put it in, it's going to triple in value when it uses the Gogins transmission in place of its powertrain now in use. And I thank you once again. Goodbye.